Okay, first we're going to start out with some definitions relating to databases. The smallest piece of information that you can have in a database is called a field. Now I'm doing this in a spreadsheet. Spreadsheets and databases have some similarities, and honestly, the database software that we're using, the spreadsheet's just easier to see. So stick with me there, but hopefully you'll get the idea. So in this case, these cells, fields and spreadsheets are called cells. These are all examples of fields. There are special fields related to databases, and that comes from putting this information together. So this is just information about people, first name and last name. Unfortunately, first name and last name, or fortunately, depends on how you look at it, I guess, is not enough information to provide a unique identification for a person. So in addition to last name and first name, we also have an ID number, so that we could have, I think I mentioned this before, but we could have two different people named Jim Bob. As long as they have a unique identifier, then we can put them in as a record in our table, and this unique identifier is called a key for that table. Okay, so we have a key for the table, we have a table, which is some collected information, and inside the table we have fields. And then in addition to keys, we can also have foreign keys. So suppose I make up a second table. This is going to include the keys from the first table. So these keys tell us something about the person. And these kinds of keys that are related to a different table are called foreign keys. And there is actually a way that it's recommended that you type in the variable name for a foreign key, FK for foreign key. This is the table 1 that the foreign key comes from. This is the table that we're putting it in, table 2, and then this is the variable name for the key in the other table. So if we go back to table 1, it's called ID table 1. And then in here we're going to have a field for automobiles and the year of the automobile. And then what this means is that, going back to table 1, Jim Bob, who has ID 1, owns a Chevy 4x4 and a Ford 4x4. Jane Bob, who's number 2, owns a Dodge. And then Robert Bob, who, let's see. Oh, sorry, Little Jim, not Robert Bob. Little Jim Bob, who's number 3, owns a Jeep 4x4. Okay, so primary key for this table is ID table 2. We have primary keys, foreign keys, fields, and tables. And we have one more thing. For each primary key in a table, we have this row of information, and that is called a record. So we have records. All right, so we have some definitions to work with now. Let's go take a look at some design ideas for databases. Okay, so that's the same spreadsheet. That's not useful. Spreadsheets, one of the basic format principles for spreadsheets is that they should be in normal form. In the process of putting a databases should be in normal form, and the process of putting them in normal form is called normalization. And there are 5 different normal forms that we're going to discuss. The first one, actually, for most of these normal forms, you can violate them, and there may be reasons to violate the normal forms, but the first one you can't. The first normal form says that you cannot have a field that has more than one entry type. So I made up a small database here, recipes. I'm going to close down this definitions. Go ahead and save. So I'm not clicking on that again. So what I wanted to do was make up a table that has a recipe name, chef, and then some ingredients for the recipe that they're making. So Jim specializes in waffles and basically takes a frozen waffle out and sticks it in a toaster. Good for Jim. And Bob specializes in cereal. He does a little more. He takes the cereal out and pours some milk on it. So he's got more ingredients. So the question is then, how many fields or how many columns should we have for the ingredient list? Well, it's variable. If you've ever seen a recipe by Emeril Lagasse, good food, but he tends to have a mile-long ingredient list. So this would be a variable length column, and that's not something that's just not allowed. So if you go over here, this is a database that I made quickly. I added a table called recipes and gave it name, chef, ingredients. Ignore this last column. We don't need that. And then if I go over here to inserts, you can actually start typing stuff in. But look at what you get. You get the ID for the recipe, the name, the chef, and you get exactly one column for ingredients, and that's it. So there's no place to put anything else. So with a database, you can't possibly defy normalization rule number 1. Well, I suppose you could put a comma-separated list of ingredients in here. Cereal, comma, milk, but that would sort of really defeat the purpose of having a database of ingredients. Okay, to look at second normal form, let's pretend that we're going to maintain a database for some kind of media outlet that deals with recipes and chefs. So we're going to have information about the recipes, we're going to have information about the chefs, we may have information about the show, and other kinds of things. So we take a very small database that has a recipe and a chef. These two columns are keys that make up the primary key. So you need both of these pieces of information to then store information about the recipe that you have, because people make mac and cheese in a different way. So just saying it's mac and cheese is not enough. I need to know that's Jim's mac and cheese or Robert's mac and cheese for the sake of this particular table. All right, so we have mac and cheese made by Jim, and then somebody decides, you know what, I want to add in some information, give a little history on the recipe. So I'm going to go back and do a lot of research and figure out who is the first person ever to make mac and cheese. And so let's say that turns out the first person to ever make mac and cheese is Jane. So now we have then a third column for creator. This database is not in second normal form because there's an issue here, and the issue is that this column, creator, is only related to recipe name. Now there are two keys here that make up the primary key, and then this key only gives us information about this key, or part of the primary key. So a database is in second normal form if each column gives information that uses the key, the primary key, and the whole primary key. And again, creator is only using part of the primary key, recipe name, it's not using chef. And the issue with that is we get redundancy. So you're looking at this going, well, it's a database with two different records in it. What's the big deal? So again, you have to think about databases that are incredibly large, like Facebook. I think I've mentioned this before maybe. Recently was reading a book about databases, and Facebook adds 7 petabytes of information to their database a month. At the moment, that's the pace that they're going at. You'd have to assume that it's going to be higher in the future. You don't want redundancies in those kinds of databases. So this is going to create redundancies. We're storing information here about the recipe name in a database that also is indexed by chef. So not a good idea, not in second normal form. So moving on to third normal form. It's a similar idea to second normal form. Now suppose that we have episodes that we're going to create, and each episode is going to have a recipe, and then somebody decides, you know what, I want to keep track of the calories for the recipe. This is a very similar issue to what we had before. In this case, the primary key is going to be just episode. And then each episode we're going to say has one recipe in it. Then we have this column calories. But what does calories relate to? Calories actually relates to recipe, and recipe is not part of the primary key. So a database is in third normal form if every key or every column references information to the primary key. And the reason for this, again, has to do with redundancy. So if we're keeping information in here about hot dogs, we may have a bunch of different episodes that people are making hot dogs. And for every single episode where you have hot dogs, then you have to keep track of how many calories the hot dog has. And you run into other issues here in terms of updating this information. So suppose that you had this huge database and you had, let's make some stuff up here. You had 1,000,000 episodes that aired hot dogs. Well, then suppose you found out that, oh, wait a minute, I need to update the calorie information on hot dogs. Well, now you have to go searching through this episode table and find every instance of hot dog, make sure it's updated, go look through other tables that might possibly contain calorie information about hot dogs, make sure those are updated. It's much more efficient to just have a table that has different food groups, hot dogs, and list their calories. And then if you ever need to update information about calories, you just go to that one table, update it there, and it's automatically updated everywhere else. Okay, so second and third has to do with redundancy of information. Now we're going to move on to the fourth. Okay, so in the fourth normal form, I am looking at, I have a primary key, which is going to be the ID. We have a chef, Jim, and an episode. And then we have cooking styles that have been mastered by this chef. So the issue here is that these two pieces of information, although related to the chef, which is the chef is really going to be part of the primary key, these two pieces of information are both related to chef, but they're unrelated to each other. It's called being orthogonal to each other. So the question then is, how do I store this information? So I have this chef Jim who's made 2 episodes, and he is really good with cooking possum and crawdad. And then I have this chef Bob who's been in 4 episodes, but he's got 3 cooking styles. He's mastered French, Italian, Moroccan. Well, these aren't tied together. So I put the French, Italian, Moroccan here, but I could have just as well put it there. It doesn't really matter. I made this a null value because these again, pieces of information aren't related to each other. Or I could have come over here and for each episode that Jim is in, put down his cooking styles. So season 1, episode 1, put down both possum and crawdad. Season 1, episode 2, put down both possum and crawdad, and do the same for Bob. This is what's known as doing the cross product of 2 tables. That's a lot of redundant information. Or third method is I could put in chef, put the episodes as null, and then put the cooking styles in. There's 2 cooking styles for Jim, possum and crawdad. Put in then the episodes with 2 null values that Jim was in. So he's in 2 episodes, put those in, and then put the cooking styles as null. And then do the same thing for Bob. Put his cooking styles in, and then put his episodes in. And I think you can see all 3 of these are equivalent to each other. They both give us information about Jim and what episodes he's been in, and they give us information about the cooking styles that Jim knows. And the same thing with Bob. The episodes that Bob was in, cooking styles Bob has mastered. All 3 of these different tables give us that information, but well, which design do you use? And there's plenty more designs that would give you the same information. I can reorder these any way I want. It just doesn't make sense. So I think what you can see from this last one in particular is that perhaps the best way to do this is actually have 2 separate tables. So we could do the exact same thing by creating 2 separate tables about the chefs, and have one have the chef with their ID. Actually, in this case, the chef could be the primary key, and then have episode information about them. No, sorry, they would have to have a primary key. Have chef information, and then information about the episodes they were in, and then have another primary key, chef information, and their cooking styles. The tables would be much shorter, and in this case, you wouldn't have any decisions to make in terms of updating information. If you needed to update an episode, you can just come into this table and update it. You wouldn't have to make weird decisions about how Suddenly Jim appears in another episode. Then how do I add that information? He's in season 3, episode 1. Do I put that with crawdad or a null, or how do I do that? No, it's just an episode information. Okay, so fourth normal form means that your table should not contain information related back to the primary key where these two pieces of information are orthogonal to each other. They are unrelated. Okay, looking at fifth normal form. Fifth normal form has to do with breaking tables down into their smallest possible pieces so that we don't have redundancies. I'm going to look at first an example where this example is in fifth normal form. So we have a chef that has created 2 recipes, or presented, what I should say is presented 2 recipes. So this is going to be a table about recipes that chefs have presented to the public. And Jim presented his mac and cheese recipe by TV, and then his possum recipe by the web, and Bob presented his squirrel recipe by the web. Okay, no problem. But now suppose that instead we have a rule where Jim, every time he presents a recipe, Jim is technologically savvy and likes to get his face out there, so Jim always does TV and web, and Bob, on the other hand, always does TV. So this is going to look familiar. This is related to the whole idea of fourth normal form, but not quite, because Bob doesn't always do web. So this isn't exactly a cross product of recipes with TV web. But what we do see is that we have this rule where, again, Jim always does TV and web, Bob just does TV. So what that means is we should create a table that encompasses that rule: Jim, TV, web, Bob, TV, and then recipe information for Jim, mac and cheese, and possum, Bob, squirrel. And then we know that when we come in here and look at this recipe, we can go cross-reference this with Jim's chef information and figure out, okay, which media did Jim use to present this recipe? Oh, Jim always does TV and web. And it gets into this idea again of updating. If the rule changes and suddenly Jim decides, you know what, I'm going to add a third venue, then we can update this table pretty easily. Or if Bob decides he's going to start doing the web, we can update this table, and then all this information about how they're presenting these recipes to the world is automatically updated. Instead of trying to come in and update a big table and finding instances of Bob and updating everyone, these ideas of breaking these tables down into smaller tables really has to do with how easy is it to maintain your database. And breaking the tables down makes it easier. You create more tables, so it seems like more work, but in terms of maintenance costs, you're better off. Okay, so there's an overview of first, second, third, fourth, and fifth normal form. General guidelines for creating and maintaining databases. Hopefully that'll make sense. We're going to have some exercises soon to check to see.